not done any f of x in here. This is taking you back to Algebra 1 and Algebra 2, see if you can remember. If f of x is 2x plus 9, and f of a equals 7, then what does a equal? And those go together. So kind of think it as those go together. See if you can come up with it. A's answer is 9, B's answer is 23, C's answer is -1, and D's answer is 7. Now I'll go over, but I'm going to see if you can. This is a harder one, I'm telling you right now. It's a little tricky. See if you can figure it out. If f of x equals 2x plus 9, and f of a equals 7, then a equals what?
Kind of nervous about this one.
Uh-oh. It's a little tricky.
Is it?
If you think it through, you can do it, but you got to think it through.
Just see what happens.
You got some people sweating over here. Good thing I don't tell people who got what. I just show a graph. That's a good thing, right?
Yeah, that's right. I mean, I'm gonna say I got right here. I had it wrong.
Which one did I have?
Huh? Okay, whichever one you want, it will take your last answer. So whichever one you hold up, it will take your last answer. Okay. Is that everybody? I can take Jessica. I can take her. Yeah. Okay. Now, real quick. Does everybody realize this is just a substitution problem? Do you realize what that is?
Yeah.
Okay. What did they do with the x? They made it an a, right? So they said, okay, let's not make this, I'm not changing it, I'm already working. They said, let's not make this an x, let's make it an a. So now they're saying f of a is going to equal 7. So what can I do?
I got it wrong.
And is? Some of you got it right. What did you do? And what were you trying to get it to do? Okay. Can you not just plug the numbers in here and see which one's going to give you 7? Would that not work? So let's, 2 times 9 plus 9, is that going to give you 7?
No.
No. 2 times 23 plus 9, is that going to give you 7? 2 times -1 plus 9, is that going to give you 7? You could have also done the algebra. You could have said 2x plus 9 equals 7, and you could have solved it. Okay? Now, it's a good thing I don't tell anybody who got what. Let me just show you the graph. There we go.
Can't tell you. Cannot tell you.
You did good. You did good.
Got it wrong.
Once again, keep in mind that is one we have not done before. That's completely new. Oh, the pen's over here. All right, you got 2 learning targets. Notice that.
One should already, or no, never mind. You weren't here yesterday. You should have gotten a new colored sheet of paper. Did you get one, Cameron?
Yeah.
Did you get one, Christian?
No.
Not in what color?
No.
Where were you at? You were.
Physically, you were in this building. Remember you signed off on the day that you missed.
You'll have to get the one from yesterday from Dre, who was here, who says he wasn't.
These have a lot of words, so it's going to take you a few minutes. I wrote the actual one from the test. All the big words.
Bum, bum, bum. Did they have to write anything on that new sheet, Unit 2 or anything like that?
They put Unit 2 and then they just started the learning targets because the units are kind of
So they
pieced
should have
together.
4, 5, and 6 on there.
Yes. Chris and Cameron, you both talked to Mr. Lashley, right?
Yeah.
Okay. I told him there was a couple students that was going to be talking to him. He said they. Okay.
I told him like the same thing I did for homework.
Good deal. Good deal.
Let me know when you are done writing them down. There you go, Bo. Got it done. Okay, well, very good. So, right. Those that are done, go ahead and go to your next sheet of paper, put exponents. Today's date.
Hi, Dave.
Pie day for Miss Gardner. She's got her pie shirt on. Sure, Mr. Feldhouse has a tie on.
That's just before I won't. If you find out, I will gladly do it.
All right, everybody good? Cameron, you need more? Okay. Exponents in today's day. Now, what do you all remember from last term about exponents? Anything? They're annoying? Valid. You remember the rules? Not at all? You know what I mean when I'm talking about exponents, about like simplifying exponents? You don't remember any of the rules?
Are you talking about the one where you had the box?
No, not the box.
That's absolutely.
It's an absolute value. Multiply and polynomial.
Give an example up there so they
Is
can
this
hear
with,
what you do.
with like a, like,
So if we have a squared b to the third times
Oh, it's this?
a to the fourth b
Oh, okay.
to the sixth.
Oh, yeah, I remember.
How would we simplify that?
You would add the exponents.
Add the exponents, right?
Yeah.
So it would become what, Chris? A to the
6,
and b to the
9,
Now what if I have
division.
2a to the third, b to the fourth times 6a to the sixth, b to the fourth.
You multiply the numbers and then add the variables. Right.
Multiply big numbers, right?
Yeah.
So that becomes 12,
8 to the 9.
A to the 9, B to the 8. Everybody remember that?
Yeah.
What if we have x to the 5th over x to the 3rd?
Keep subtracting, they become x to the 2nd.
Would it be on top or bottom? Why?
Because it's the bigger exponent.
It's the bigger exponent. Everybody remember that? Division, now if these were switched, you had x to the 3rd on top, x to the 5th on the bottom. So if we had, instead we had this, then what would that be?
1 over x to the
1
2nd.
over x squared.
Why is there a 1?
Because it's a set fraction, though, so it has to be a 1 above it.
Well, can I leave it blank?
No,
Can I put a 0?
no.
Okay, just check.
Because these two aren't the same thing, right?
No.
Okay. All right, so let's go through real quick, do our rules. Just a little refresher. So, first rule we have product rule, which we just went over a little bit. Our little example. X squared times x to the 3rd equals what?
Is it negative x?
That's just our example.
X to the 5th.
It's x to the 5th.
X to the 5th, right? So when we multiply, we add the exponents. Okay? Now, what if I had x squared times y to the 3rd? What would I do with that?
You would leave it x squared, y to the 3rd.
But it says add exponents. Why can't I
Yeah,
have
but
x, y to the 5th?
Because it doesn't have the same, what's it called, variable, I think.
No worries.
I
So,
love it. Thank you.
must have same base. Okay? Same variable as Chris said, same base, whatever works. Okay? Everybody got that? What's our second rule? Starts with a Q. Come on, Chris.
Means dividing.
Oh, yeah, well, I don't know the real word for it, but I know if you divide, and if it's negative, you move it up or down.
Oh, he's even getting ahead of it.
Oh, we're at, no.
So we have the quotient rule. Which is just if we have x to the 6th over x squared, that gives us what?
X to the 4th on the top.
X to the 4th. Now he said on the top, so what's another way we could write it instead of just x to the 4th?
X over 1.
So we could write x to the 4th over 1. Because if you see it where it's going to be on the bottom, you got to put that 1 on the top. So I mean, I'm fine if you want to go ahead and write it like this, with the x to the 4th over 1, or if you just want to write x to the 4th. It's the same thing. X to the 4th over 1 may help you to remember that you, hey, if it's the other way around, I got to put that 1 on top. So I'm going to put the 1 on bottom, so I remember to put the 1 on top. All right. So what do we do with this one? We just subtract. Subtract exponent. Now, we're going to have the same base again, but we're not going to write that again because pretty obvious here, right? And then the last one that we did not do an example of, anybody that remembers gets bonus points. Not really. We have the power property. Does anybody remember what this one is? What it looks like? Remember, Terry? What are you thinking?
Is this knowing where If it's a negative, you move it up or
No,
down.
negative. We're not gonna do, you'll have one negative problem today, and that's on your homework, just see if you remember how to do it.
It has numbers involved.
It doesn't have that number. Oh, it has exponent numbers.
It has like big numbers involved.
Good.
Oh, they're all good.
But I don't know.
I have x squared to the third.
Oh, you multiply them.
Good.
What's a good way to remember that we need to, when we see this, we need to multiply? What's something that kind of jumps out to remind us?
Parentheses.
The parentheses. Make sure when you see those parentheses, a lot of times when we see parentheses, remember to multiply. That kind of helps you. You see a parentheses, something in and out, make sure you multiply.
Now, what if there's a number in front of that x?
Then you just add the.
No, you would
Let's say here, let's say I have,
one to the cube.
if I have 2x squared to the third,
You cube two and then multiply. that.
right? Because really there's a 1 right there in front of that 2, so it has to be distributed into both, right? Now, it's not 2 times 3,
It's 2 to the third power.
2 to the third power, right? So that gives us 8.
Is there a fourth rule?
Nope. Those are your 3.
So they're not dividable.
Well, that's what the second rule is. You won't ever have to divide the exponents. That's what you're asking.
Now, the multiplying is just because you have some groups in the parentheses.
Now, let me ask you this, though. What is that?
1.
What is that?
1.
So anything to the 0 power is
It's 0.
1, right?
Well, since there's a 0 exponent, it's always going to be 1.
Right, right. Anything to the 0 power, right? So let's make sure we write that down. Little star if you want to. Anything to 0 power equals 1.
And don't forget you have a calculator. If you ever forget, check it. Put something to the 0 and see what it tells you. It can kind of help you out in case you forget.
Any questions so far? It's starting to jog your memory.
Yeah.
Remember how to do this? We did this, what, about, it was early on in the second time, wasn't it?
It's been a while.
Has anybody seen any of these on Ed Ready?
You're in the exponents of
Chris, Christian? Do you remember what to do?
Yeah.
Good. Good, good, good. All right, let's do a few examples, then we'll do some homework. I'm not gonna do a product rule because I feel like you all are pretty good with that. We did a bunch of those at the beginning, so we're gonna move to this here. So if we have x to the 4th, y to the 3rd over x to the 3rd y times x 7
Does this have 2 steps?
2 steps, yeah, we're gonna jump right in here. Head first. Hang on. X, Y. Okay. So, the way that I like to do it, now this may be different for some of you, but the way that I like to do it is to go straight across. And then worry about the division. Now, it's possible that you could divide that out first on each side, and then multiply it. So if I go straight across on the top, we're not even going to look at the bottom. Everybody still see that? So if we go straight across on the top, what am I left with?
X11 y.
X11, Y, 8. Alright, then we go straight across on the bottom. We have X, 4. Why is it 4?
Just X is one is going right there.
Because if there's nothing, if there's no exponent, then what's assumed is there?
1 X.
1. Is that the same thing for this y?
Yeah.
Okay. So we go x to the 4th, y to the what?
3rd.
3rd, okay? Now we can go and divide. So what happens when we divide? We subtract, so I get x, 7, y, 5. That's on top, right?
Yeah.
Everybody good there?
And that's the same thing as putting 1 underneath.
Right. Same thing. Same exact thing. Alright, number 2. Just gonna do 3. If I have 4x to the 3rd, y to the 5th, n. We're gonna cube that. What's first?
4 to the 3rd.
4 to the 3rd. I'm gonna write it out. So we get 4 to the 3rd, so we distribute that there. Then what?
X times 3 and y times 3.
So x, 3 times 3, so we go there. Y, 5 times 3, so we go there. And m is what times 3?
3.
Huh?
When you said n.
1.
1 times 3, right?